So for problems 20 through 22, we're going to use the region bounded by y squared equals x plus 1. So that is this curve. And then y equals x minus 1. So the first thing that we want to do is actually find, I labeled it here as 3, 2, and this is going to be the point 0, 1. But if we don't know those points, we want to solve the equation for x and y. So if I have y squared equals x plus 1 and y equals x minus 1, I can substitute, since y is equal to x minus 1, I can plug in x minus 1 here using substitution. So we have x squared minus 2x plus 1 equals x plus 1. So I have x squared minus 3x, and that's going to be equal to 0. So I factor out, I get x times x minus 3. So x equals 0 and x equals 3. By plugging back in, we can see 0, 1 and 3, 2 are the 2 points where the two graphs intersect. So to find the area of the enclosed region, I would use right minus left. And so in order to do that, since we're going to do right minus left, we want to have everything solve for x. So for example, if I have y squared equals x plus 1, then x is equal to y squared minus 1. And here, if y equals x minus 1, then x equals y plus 1. Now looking at the region bounded, the right is going to be bounded by the line. So my area is going to be the integral from, again, since we're in terms of y, we're going to use the y coordinates of our bound. So it's going to go from 1 to 2, sorry, that's actually a negative 1. Negative 1 to 2. Okay, so our right bound is going to be y plus 1 minus, and our left curve is going to be y squared minus 1 dy. Okay, so we're going to just plug this into the calculator. So on the test, again, I'm just going to ask you to do the setup, and then you can do the calculations with your graphing calculator. So I have from negative 1 to 2, and it's going to be y plus 1. So we have x plus 1, and then it's going to be minus y squared, so minus x squared, and it's going to be plus 1 because minus negative 1. Notice we don't need any pi here. We don't need anything radius squared. It's just the area between the curves. Okay, so when I integrate that, we get 4.5. Okay. Next, find the volume of the solid generated by revolving the region about the line x equals 3. So x equals 3. We have here okay, so if you can kind of imagine, this region here is going to go around the curve that way. So if you recall, we did this worksheet where we summed up what happens when you revolve a region. It's not about the x or the y-axis. So here's an example that we did. The line of rotation is to the right of the region to be rotated. So in this case, we're going to be taking the line minus the outside curve, or the line minus the inside curve. Okay, so in this case, so if I just consider big R, my big R is going to be 3 minus, and that's going to be the outside part is going to be the parabola. So it's going to be 3 minus y squared minus 1 And my small r is going to be 3 minus, and that's going to be the curve here, the line, and that's going to be y plus 1. So my volume is going to be pi, integral from -1 to 2. So we have big R squared minus little r squared. So that's actually going to become, so if I do 3 minus y squared plus 1, that's going to end up being 4 minus y squared minus little r squared. So that's going to end up being 2 minus y squared dy. Okay, so let's check that. That's going to be math. 9, we have from -1 to 2. So we want 4 minus x squared minus, and then 2 minus x quantity squared dx. So I get 21.6, so it'll be 21.6 pi, which is about 67.858. Okay. And number 22, set up but do not solve an integral representing the region revolved about the line x equals 5. So x equals 5 just means I'm going to move that region over. And it's going to be set up very much the same as the rotated about the line x equals 3. It's just instead of 3 minus the curve, it's going to be 5 minus the curve. So actually, I'm just going to show you here where I have it already set up. So it's, again, to figure out r, big R, it's going to be 5 minus the inside curve, which was y squared, what was it, y squared minus 1. So that's how I got the 5 minus y squared plus 1, or some of you might have combined this to make this 6 minus y squared right here. And then the other part, the little r, is going to be, it's going to be 5 minus, and then y plus 1. So that's how we get the 5 minus y minus 1, or simplifies to 4 minus y. So again, just setting up, but do not evaluate. The bonus, yeah, you can look it over. The extra credit problem that I have on tomorrow's test actually looks different here, but you can look at the volume of the sphere and the volume of the piece cut out and so on.